So as Dom said, I'm a back-end engineer at Monzo, and I'm here to talk about what I'm doing at the team there, which is called the Developer Platform Team. And we focus on improving the developer experience, so the people working on the stuff that's building Monzo. And I'm also a rubbish gardener, but that doesn't stop me from making that the theme of this talk. I think that there are lots of parallels between the practice of gardening and of growing software, so I've made that the theme. While I was putting the talk together, though, I did see this tweet. Programmer with hobby. So you see, hobby is not only the perfect metaphor for programming. There is a much deeper fundamental connection. Indeed, the best programmers do hobby. Yeah, I'm still going to go with it. So it's a little bit about me. Like I say, I'm a back-end engineer at Monzo, and I've been there for just under 2 years, but I've been doing software development for probably 15 years, almost entirely back-end stuff, so in .NET most of the time, but Monzo is at Go, so I had to learn everything from scratch again, which was fun. In my previous flat, I had a little kind of pop-up greenhouse. I didn't know they existed until I had a rented space. They're fantastic. They are literally just tents that are see-through. And I grew bell peppers and cucumbers for gin. And I was very, very proud of myself. I considered myself the accomplished gardener with my 5 cucumbers and 3 bell peppers. And now I've got my own little place, and I have a garden, and this is my garden. And it's overshadowed by these huge oak trees, which are beautiful to look at, but they block out all the light completely. So nothing actually grows, which made me very, very sad. And in winter, all the leaves come down, and for like 2 months of the year, I am shuffling leaves. So despite wanting a garden to garden in, I can't do any of that. It's mostly just there to keep the cats happy. Cat tax. The houseplants, though, are doing a whole lot better. So I'm focusing on those little guys instead. I have to be very careful to get plants that the cats will not be toxic and die from, so they chew everything. Okay, so we keep saying that word Monzo. Has everyone heard of Monzo? Are you customers? Fantastic, brilliant. Thank you so much. But in case everyone didn't nod their heads, I'll give a little bit of an overview. Okay, so we're a bank. We have just turned 5, like Monday, I think we turned 5 years old. And we're a full bank, so we're regulated by the Financial Conduct Authority, and the money is protected by the FSCS, and there's about 4 million customers. It's an entirely app-based bank. There are no branches. And it provides you brilliant visibility into your finances. Those slides look really squished, I hope you can see. So you get like all these notifications when you spend, you get budgeting features, you can freeze your card, no foreign card transaction fees, pots, and so you can spend your money from your pots, your bills, and yeah, just generally loads of people found it actually improved their financial lives massively. Okay. And the architecture built from the ground up to be scalable. And it's a microservices architecture running on Kubernetes in AWS. We use RPC and asynchronous events, and the backend code, like I said, is almost entirely in Golang. It's also stored in a monorepo. And so that means that there's a single Git repo containing all of those microservices. There's a whole blog post, I will send you the slides later, which goes into more and more detail so you can see exactly how that architecture is put out. But basically it's quite big, it's quite complex, and it's quite unique. And this tweet came out. You may have seen it. There are 1,500 microservices at Monzo, and every one of those lines is an enforced network rule for allowing traffic. The furore on Twitter was ridiculous. People were up in arms at this. I think this got more replies going, how on earth does the bank work, than people liking it. I think this was Jack's first tweet as well. He's now famous. He's called Jack from Twitter. It's just, yeah. So everyone thinks it looks a bit like that, right? Like a complete and utter vine-overgrown mess. But it's more like a sunflower. Did you know that the sunflower head is actually thousands of individual flowers just coming together into one head? Yeah. So it's actually more like that, all these individual little services working together to create the bank. Even the petals on the edge, they're individual flowers. There's an updated image, which kind of helps a bit, as in he's put them in color and by team. So you can see that no one needs to know the whole platform. There are domains within it. It's not a complete mess. And there is some rigor to that structure. Okay, I need some water. So when I talk about developer experience, what do I mean by it? I mean what the engineers do to get that stuff developed. So when we talk about building the product, we think of the customers and how the software can be built to make it easy for them to perform their tasks. So that's user experience, right? And I'm suggesting we do the same research, the same thinking about how our developers perform their task, the task of building the software. So to build the product, we use lots and lots of other software, other tools. And some tools will be off the shelf, and some we will have built ourselves in-house. But many of those will have been created or bought to scratch a particular itch. In user experience, the user's goal is they have a reason to use that product. And the developer's goal, like I said, is to build the software correctly and efficiently. But the developer experience is often neglected. And the software building process tends to get a few cracks here and there, and and they're only really discovered at the worst times. For example, do the backups of the source control repo really work? If you're not on GitHub, that is. And things like that. Like at the worst time you discover your deployment process can't handle something. And a bottleneck in the process that a developer has is generally overlooked, those tooling things that aren't quite right or finding the cracks. Because the only people who see it are the developers. So why would we even focus on giving developers a better experience? What's the reason that we would put time and effort into this? So the science behind this, there is actually science. In this book, you may have seen it, Accelerate, by Nicole Forsgren, Jez Humble, and Gene Kim. And this is built upon the State of DevOps reports. They were industry-wide surveys performed over years. You may have actually filled them in yourselves. And the data was rigorously analyzed using peer-reviewed statistics, and they drew correlations between certain practices and the performance of IT teams. And this book goes into those correlations and the science behind it. This is a snippet of the findings in the State of DevOps report from 2017. I'm not expecting you to read it all. You probably actually can't, to be honest. But these are the 4 key factors they found that indicated whether it was a high or low performing team. So we'll see at the top here, we've got deployment frequency. For high performance, they'll be on demand, maybe once a day or more. For medium performers, probably about once a week or once a month. Low performers, about the same. And they've got lead time for changes, which is the amount of time it takes to get from a code being committed to the code being running in production. And again, on high performers, that's closer to less than an hour. For others, between 1 week and 1 month. And low performers, again, same thing. So think about that will be the period of like maybe needing a CAB meeting or getting the user testing done. There'll be lots of processes that other places will have in that gap there. Mean time to recovery, so that's how long it takes for an issue to get resolved in production. So if there's an outage, if it takes you an hour for an outage to be solved, you're higher performing than other places that can take between 1 day and 1 week. Can you imagine a bank having a day or a week of outages? And at the bottom there is change failure rate, which is how many of those releases result in needing a remediation of some sort, being fixed. And in high performing, that's low, that's like 0 to 15%. But in those really low performers, 31 to 45%. So what you can get out of that is that people who do less releases, less often, actually have more mistakes. And the developer experience, I think, focuses on those first two, because they're the things that the engineers themselves go through as they are building the product. So that is, if we can help improve their experience, we'll improve deployment frequency, we'll improve the lead time for changes. The other two are also more of an ops experience. The code does change those things. If you don't put in the remediations in your applications, you can't impact these. But they're kind of after you've done the deployment. So, continuous delivery. I'm sure most of you are already aware of the concept, but I'll give a quick overview for everyone. There are 5 principles of continuous delivery, and they are: build quality in, work in small batches, computers perform repetitive tasks and people solve problems, relentlessly pursue continuous improvement, and everyone is responsible. So build quality in is about it being cheaper to fix a problem and defects if you find them immediately. So by having smaller and shorter feedback loops, such as running tests locally or getting into production soon, you'll actually find problems before they become big, scary things to fix. Working in small batches, which reduces the time to get feedback, so you can fix those issues and reduce sunken costs. And get the computers to run things like automated testing and leave the humans to do exploratory testing, find the things that computers aren't very good at. Relentlessly pursuing continuous improvement is about not treating a transformation as a one-off task and then going back to normal. So you can't we're done now, agile. No, it's treating everything as your daily work is improvement. And while everybody being responsible for, say, quality, it's not just quality assurance people, for running the app smoothly, it's not just ops people, most people want to do the right thing if they're supported and allowed to do so. It generally leads towards an automated CD pipeline. So here's an extremely simplified version, where almost all of it is automated, and a failure at any step will halt the pipeline and return it back to the development phase to be fixed. So that we have a feedback loop all the way to development. And I mentioned bottleneck earlier. So what did I mean by that? So this is where we talk about theory of constraints. This book here, The Goal by Eli Goldratt, is actually, you've probably already read this without knowing you've done it. It was rewritten in a book called The Phoenix Project. This book came first. It was built on the concept of manufacturing. So it's a story, and through that story, he asks the questions, and you come through to the same principles that are in the Phoenix Project, which is the theory of constraints. And the core concept is that every process has a single constraint, and that the total process throughput can only be improved when that constraint is improved. And improving any other part of the system is a waste of time and energy. So for example, if you fix tooling for a certain situation, it may not fix the problem overall. So local optimizations don't always create a global optimization. There are 5 focusing steps to help you with the theory of constraints. These are: identify the constraint, exploit the constraint, subordinate everything to the constraint, elevate the constraint, and then repeat. Yeah, I don't like that either. What the hell does half of that mean? So I rewrote them. Find the weakest link in your chain. Use it to its maximum. So if you find that weak link, because it comes from manufacturing, they talk in the book about a cooking machine, cooks these pots for the next step before they can be painted. And instead of doing batches at a time, they decided to use the cooking machine 24/7 and had shifts around it. So use it to its maximum. Make everything else wait. There's no point in doing anything else and building up things that can't be cooked or can't be deployed or can't be tested. until you've managed to get it through that stage. You end up with inventory and obsolescence. And it's also where WIP limits came from in Kanban. As in, there's no point in you doing more than 3 tasks at once if someone below the next step in the stage cannot take the tasks at the rate you're developing them. And then pay to expand the bottleneck. That means only then, only after you've managed to get as much as you can out of this bottleneck, do you throw money at it. To build, like hire more people or just spin up more servers or whatever. And then start again. Because you may have a new bottleneck now. So we created the developer platform team with the goal of finding and improving bottlenecks for developers building the bank. So that's the preamble behind why we did this. Because we felt it would actually help the company towards their goals, and there's science behind it. So we initially treated this problem like engineers. We were like, okay, we have this problem we want to solve, and what do we do with every problem we want to solve? We put metrics on it. Yay. So we instrumented as much of the developer flow as we could to get these metrics. Here's a book here that I recommend called Measuring Continuous Delivery by Steve Smith. It's a lean pub book. And he goes into how certain indicators can indicate the health of your system through continuous delivery. Here's one key part of the metrics. He says combining these, you get an idea of system stability and the throughput of changes. Ideally, you want both high stability and high throughput. And these metrics are pretty much the same metrics that came out of the State of DevOps reports and Accelerate. Over time, track it and look for trends. So, failure rate and failure recovery time together create stability. Lead time and frequency can create throughput. Seems simple enough, right? We tried that. We collected metrics on pretty much everything and tried to create these trends. I'm not expecting you to read it all, but we collected how many deployments in the last 30 days, which things were deployed, how long it took to merge the PR, how many unique targets. These metrics are great fun. I know you can't see them, but we found out, for instance, that if you open a PR on a Wednesday, I think it is, no, not a Wednesday, a Monday, it gets merged much quicker than if you open it on a Sunday. Don't work on a Sunday. But yeah, it was mostly vanity metrics. It didn't really help us out. We tried again, based on Steve's book. And we tried to collect the throughput metrics. So we've got the deployment frequency, and we've got the change throughput, so how long it takes to get a PR merged. So I should mention here as well, we use PRs because as a bank, every change has to have a second set of eyes on it before it can go to production. And that's the process we do for that. So we try and make that bit of the process as fast as possible. But again, we couldn't see any trends in this. Like, it's really flat, apart from Christmas. That's Christmas up there. This one in the top right is a percentage of closed pull requests merged and unmerged. So when a PR has been closed, was it merged or unmerged? So implying whether we've got wasted work. That doesn't really tell us anything either. Most values weren't obviously good or obviously bad, so it was really difficult for us to prioritize work around it. We couldn't also track a change through the engineering process because everyone was using different tools. Some were using Jira, and some were using Notion, some were using Post-it notes. And from our point of view, waiting for a build, reviewing and closing PRs is just a small part of the engineer's experience, the developer's experience. So we had blind spots that the metrics didn't highlight for us. We could probably have fixed it, and we could probably drill down into the results a bit more, but it would have required a serious investment to find this. I think it's a factor of our architecture, which is why I mentioned it before, the scale of things that we have and services. So we thought we'd take a step back and treat our engineer experience like a product. I like this picture. So what I mean by that is that We wanted to learn from user research and learn from them how they actually get information from the customers to build the best product. Maybe we can do the same and build the best experience. And this is actually really easy at Monzo. Everyone, the user research team wants everyone in Monzo to feel closer to the customer. So they created a research starter kit. It doesn't aim to turn everyone into user researchers, but it gives them the basic tools to help them understand their customer. So we took advantage of this. There's a blog post here that is out, which already covers more of this in detail, but I'll give an overview. So it's both, the user research starter kit is both a 2-hour workshop and a bunch of written documents and external resources. The user research team also offer weekly open office hours, which you can book with them and ask questions or get a second opinion on your research. So you get a brief overview of cognitive psychology. So this term is coined by psychologists, you'll probably hear more about this from maybe Gail later or something, to refer to the mental effort required by a user to analyze, process, and understand information and any barriers or obstacles they encounter while doing so. Cognitive load. It studies the psychology of a person's attention span, memory, reasoning, and other actions of the brain that are considered a complex mental process. So we wanted to build our system to reduce the cognitive load of the developers. So we needed to choose a research method. It turns out there are different kinds of research methods you use depending on where you are and what you're building in the process, like how far along your application is. In the discovery phase, the design and build stage, the optimization stage. In the discovery phase, you'll use things like in-depth interviews, phone or in person. You'll do field visits or contextual observation, diary studies, surveys, desk research, which basically means reading other people's research. In the design and build phase, you'll do user testing, so either in person or a lab. You'll do unmoderated testing, which is where you ask people to complete a task and just watch them. You'll do pre-alpha diary studies, tree testings, which is findability in menus. And then when you've got your application built, to optimize it, you'll talk to the customers via lighter touch things such as emails, phone calls, surveys. We figured that even though we have a developer experience, we had no basis. So we were actually in the discovery phase. And we chose to do interviews and surveys. So a survey seems a real simple and low investment way to get an idea of how the engineers feel about their development process. The aim was to benchmark the current state, put a finger in the air, and find some low-hanging fruit of things that we could easily fix to make small improvements. The first survey we did without any input from user research. We didn't know about the user research starter kit properly at the time, and we made a few mistakes. We put in a lot of unnecessary questions, such as asking people their name and asking them how long they've been in the company, what their role was. We could get all this information using the internal HR system, like their email address in the survey, and look it up. We asked big open-ended questions, which people were reluctant to just spend 20 minutes of their life filling in for us. And they gave us, and if they did fill it in, they gave us full paragraphs of information that we would then have to be able to manually parse through and figure out what's in there. So the investment of us was actually far higher than we thought. It was like, oh, we'll just throw out a survey. Yeah, you've got to really design them in such a way that the information that comes out is useful. And we couldn't really trend anything over time. We still found a few things out of it, though. We still learned a few things. The majority of engineers did feel set up for success. The stability of the staging environment was a pain point. Now, when I say the stability of the staging environment, I need to explain. It's a shared environment, and it didn't go up or down in the classic servers disappearing kind of way due to the Kubernetes and stuff that we've got. It was more that development takes place quite quickly in that environment, and some bugs can get through there because that's the point where a lot of people do a lot of testing. So if an app tester is testing on staging, they can't tell if the bug they're seeing is in the app or in the code running in staging that they're connected to. And everyone just ends up stopping and like, I can't do anything, because they don't know where or what to do about it. So it's a pain point. The local development flow felt slow. That's because originally you'd bring up all of the microservices in Docker on your local system, which no longer works when you've got 1,500 of them. Web deployments also felt slow, and we're not using the standardized pipeline as everything else. So they were like these special things that took 15 minutes to build and were deployed in a very unique way that only like 5 people knew how to do. And there were a bunch of other stuff that I think people came out with. So we decided to do the interviews to find out a bit more. I'm going to take another drink. Yeah. The first step is to figure out who we want to talk to. What kind of characteristics will those people have? Then you prepare a discussion guide, a script, to keep the interviews roughly similar and cover all the important areas. And then you need to book and hold the interviews. This comes out of the user research starter kit that we've got. So that we, this time, decided to take advice and figure out how to take the best advantage of it. So what are our cohorts? So a cohort is a group of people with a shared characteristic. So we decided that we were mostly interested in, again, the axes of role and the time of Monzo. So we broke them into cohorts of back-end engineer, mobile engineer, web engineer, data science engineer, and whether they'd been there less than 6 months, between 6 months and a year, between a year and 2 years, or more than 2 years. This is a 5-year-old company, so there's not going to be a huge amount of people that have been there a very long time. Then we need to prepare the script of what we're going to talk about in the interview. So we need to include an introduction of why we are asking people to talk to us. We need some simple starter questions to break the ice with people. I mean, you don't want to bring them in cold. And this time, unlike the surveys, we do want the open-ended questions. We know an interview is going to be high investment. We're going in and we want to hear everything that people want to tell us. And because it is a conversation, you want to avoid jumping straight into those questions. You don't want to put people on edge. Don't give them an interrogation feel. And because you are asking for their thoughts and things, try to avoid the closed questions. So closed questions are questions like with a simple yes or no answer. And then here comes the legwork. And this is the bit that can take a lot of time. You'll need to contact all the people you picked to represent your cohorts and find suitable times and book in. We booked in 30-minute chats. Any bit longer would have just not been useful, and anything shorter of the same. And we made sure to explain up front what the chat was about and why, which, you know, you're going to repeat that later when you see them at the time, but we're not testing people. We want them to be comfortable and honest. And you need to take lots of notes, lots and lots of notes. So we wrote up the notes, and we shared them. First, I would share them with the person we interviewed so that they knew what was going to be in them. You know, asking them if they were comfortable with it, if I'd missed anything out. And then I shared them with the rest of the team. So as you can see here, we were tracking the cohorts that people were in and the notes against it. And now we need to go through those findings to find the information that we're after. Again, the user research starter kit suggested building a findings log to collate the findings of your interviews. So that means going through all of the notes and pulling out common patterns, things said by more than one person, or within a cohort, for example. Include some direct quotes to support the findings. And then assign a severity to that thing. For us, the severity was a combination of impact, repetition, and frequency. So impact is how badly it affects the person doing the task they're trying to complete. Repetition is how often they experience the issue. And frequency is how many people experience that issue. And together with those 3 factors, you can find out a severity. And then maybe including a high-level fix for this. So here's a snippet of one of our findings logs. And did it load? Yes. And you cannot read any of it. Brilliant. Okay. So it's, you can get an idea of it. We basically had to collate all this information together. On the right there, you've got which people said what. There's a participant 1 said this, participant 2 said that. We have the area, the finding, the direct quote, and a kind of severity and what we would do about it. So let's take number 4 there, staging. Staging instability when creating test accounts negatively impacts productivity. Direct quote. It makes my work very slow, and if I have to go through sign up multiple times a day, and IDV is slow to arrive in BizOps, it's an internal tool, then I will take far, far longer and eat up my time. That's an app tester directly. So for example, what could we do? We could revise checks that flag created test accounts so that we can bypass the IDV step maybe. Maybe we can add an automated test which continuously creates test accounts. That kind of thing. So yeah, going through all this was very time consuming, but we got more context of the things that people were having trouble with. It was very useful. So we set about making some changes. Now, the changes themselves aren't actually the purpose of this talk. I mean, I'm not here to try and tell you the things that Monzo did and that Monzo are awesome and all those kind of things. What I want to do is inspire you to learn from the techniques of the user research teams and apply them inward to improve your own processes. But I realize the talk is not very fun unless you can see the outcomes of it, so I've got a few examples. So to help the staging stability, we did the simplest thing we could think of. It's very common in Monzo to do the simplest thing, and then if that works, build on it. So we did a simple script and ran it in Jenkins, which we don't run anymore, which just created user accounts on a regular basis, and then posted in Slack every time they failed. What that did was highlighted whether it was the platform that was having a problem, as in there's too much instability there, and it wasn't the app, for instance. So the app testers would know immediately that it wasn't something they were looking at that needed to go back to the mobile developers to fix. It was a problem in the staging environment. Eventually, it proved so useful, we turned it into a Go binary and a cron, and now it's a part of our regular system. To help with getting PRs reviewed and to not duplicate review work, we post all PRs into Team Slack channels. So that creates a single place for people to see what PRs need reviewing. And a service listens to the events that GitHub sends, and then we'll post semantic emoji so that other engineers get an immediate idea of whether that PR still needs attention. So if someone adds a comment, it puts on a little comment emoji. When someone's okayed it for approval, it gets the little tick emoji. And when it's been merged, you get the merge emoji. And what that does is it means that there's not engineers wondering about going and reviewing the same PR that's already been reviewed. You can look down this channel and go, okay, we've got 2 at the bottom that need looking at. And you can it just sped up that process quite a lot for everyone, reduced double work. We also invested time and added support for building and deploying the web projects with the same tooling and process as the backend microservices. So that reduced the overhead in making changes on the web projects and made it possible for any member of the engineering team to work on them, so they wouldn't need to learn a different way of doing things. It was quite a heavy investment, but very much worth it. But not all the changes were code. Like I said, we're engineers, we jump immediately to the code solutions, but honestly, like we talked earlier, any part of the system can be the weak link in the chain that causes everything to slow down. So one example is we introduced the staging helper role. Now, I'm pretty sure most of you teams have the concept of a point of contact person, the person whose job it is that day or that week to triage incoming issues or bugs or whatever, and then you kind of share this role and move it around. And as staging was a shared environment, there was a tendency for issues to get lost because no one felt directly responsible. But by making it a kind of temporary role, issues were handled quite quickly. So for example here, this was one of my teammates asking for more people to volunteer. And that meant that when, say, things like that user script showed that there were problems creating user accounts in the test environment, the staging helper would see that and straight away fix it. So there was less instability in the environment. So after 3 months, we wanted to know if everything we'd made a difference at all to the engineer's experience. So we wanted to run another survey. But this time, we learned from our mistakes on surveys. And we made it far, far simpler. 3 questions. Just 3. So over the last month, how much do you feel Monzo's engineering tools and processes have set you up to be effective? Never, sometimes, always. What made you give that answer? And if you could change one thing about Monzo's engineering and processes, what would it be? So that gives us, the top one gives us a metric, and the other 2 gives us some more context. But not reams and reams of context and stuff, but it's like free for people to put in whatever is currently more important to them at that time. So we assigned a number to each of those responses and created a rating based on, what have I written here? Oh, yes. So we assigned like 4 to always and 3 to things and did the maths. But there's no industry standard to measure against, but we felt 78% was pretty good. Try doing it in your own place and see what you get. But we've got nothing to measure it against. Like 78 could be awful, but we felt it was fantastic. So, but what it does is it means there's still room for improvement. Another trend is we noticed that satisfaction had increased with tenure, which is a little bit weird. So we would want to dig into that a bit further. Problems with staging were no longer mentioned when we asked people what they would fix. So it means that all of our things that we put into place to counteract it were making a difference. And people weren't talking about getting their PRs reviewed as being a major, major problem for them. So that change also helped a lot. Here's a couple of graphs. So there we go. The satisfaction rating increased based on how long you'd been at Monzo. So the people were less than 6 months, and the people who'd been there longer than 2 years. We went and took another look at the interview data, and we found out that it's because the people who'd been there the longest were comparing it to when they started, and deployments and processes were basically bash scripts and SSHing. So as far as they were concerned, we were living in the future. But the people who were new, the tools were quite unique to Monzo, the processes were quite unique to Monzo, and the documentation was lacking. So understanding what you had to do was difficult, and what you could use. So that's something we learned, and we would have to get better at doing the documentation. And the cohort of discipline. So we split that out, and as you can see there, the mobile engineers were not feeling quite so set up for success as the other teams. Again, we went back to the interview data and had a look to see if we could find out why. And it turns out that releasing and building the apps is a really complex, slow, and unwieldy process for the mobile engineers. So that's something that also would need attention. People did still request things. They requested faster builds and rollouts. And they also wanted more visibility around what has gone wrong so they can start debugging. So builds and rollouts for back-end services take a matter of minutes, so it really surprised me that people wanted that faster. And when I say minutes, it's like 5 minutes to build and deploy. But I think it's more the web apps and the mobile apps that were giving that answer. If we look at the cohorts, they were the people who were saying it's really slow. And we were also surprised to find people complaining about how difficult it was to debug their services and diagnose production issues. One of the things we did was improve our log aggregation tooling. It turns out that our system for storing log messages was struggling to cope with the volume of queries. So based on that feedback, we took the decision to move it over to Elasticsearch, and this relatively small change made our engineers very happy. As you can see there, using Kibana for slog is such a breath of fresh air. Slog is our structured logging tool that we used to have. And so much more usable than the old UI. It's like, how did we get far without this? Again, that is a case of one of those tools that starts to go rusty and snap, but no one but the engineers notice it. And at some point, the process stops working. That became our bottleneck. So we're doing a review, right? So what about our metrics, the ones that we put in right at the beginning, fancy dashboards of deployments and stuff like that? Yeah, they didn't look any different 3 months later. They didn't show any trends that we could figure out. It's likely that we just have too much data, or we're cutting it wrong, or we just maybe need some help from the data engineering team, like we grabbed help from the user research team. I wonder if it's a factor of our microservices platform, as in each individual microservices deployment speed is kind of nonsensical when you're dealing with like 1,500 of them. But yeah, that data didn't show much that could help us out. And we found the user research starter kit giving us direct feedback was far, far more helpful. We've taken the developer experience approach further, and we've created discipline-specific platform teams. We have a web platform and a mobile platform team now. And both of those are working on improvements for their developer experience. I know that the mobile platform team have greatly sped up and streamlined the deployment and build process of the mobile apps, which is obviously what our surveys kept coming up with saying, and that the web platform team have improved their deployments as well. I have gone too fast. So, to summarize with our sunflower, I want people to learn about their flow, use the tools, use the things like continuous delivery and theory of constraints to find the bottlenecks in your process and your flow. Borrow and apply techniques from user research, because metrics aren't going to give you the full picture, and on their own they can be misleading. And try to treat the developer flow as a product that you can put time into, because maybe from a business point of view it doesn't sound like it makes a lot of sense, but the science is there to prove that if the deployment is smooth, fast, reliable, your whole business will be improved. You'll become more of a high-performing IT department. But also, be patient, because every one of these changes that we put in took a long time to actually feel anything. Cultural change is slow, even on a tooling basis. And yeah, so much for a talk that was supposed to be an hour. This is a photo of my garden I took yesterday. There are actual flowers. I am so happy. You have no idea how happy I was that I have actual flowers in my garden. Like, yes, I deserve that clap. You have no idea. Thank you. Thank you, everyone.